So not everybody is capable of doing EQ mode, whether that be because of a mount that they do or don't have, or they're traveling and don't want to carry all the gear. Sometimes you just don't want to do EQ mode, so you want to do azimuth mode, and you want to reduce the field rotation because that's the hurdle, the big hurdle, in using azimuth versus EQ mode. And so I've put up this picture for everyone to see. It's a terrible picture. I know that. I don't need to get the comments about it. It was a picture I took for a different experiment, but it really shows that field rotation because I imaged M31 for 4 hours, and there were some issues with clouds and things that happened in addition, but it really does show that field rotation, and you see it mainly in the corners of your images, and this is over 4 hours. And so what I wanted to do is do an experiment or a tutorial on how we can do this same image in azimuth mode without having quite that much field rotation, because if we had to crop this one out, we would have to crop a lot. Well, another factor is this is M31, and I did not use any of the framing and enlarge it. And so if we were going to crop this, we would crop it so much that it wouldn't even look like M31 to get rid of that field rotation. So this video is an experiment tutorial about how we can avoid that much field rotation in our images when we're using the azimuth mount mode. And so we will continue. I'll show you how we set it up, and then we will show some of the comparisons, and we will do a summary at the end. So the first thing I want to do is I'm going to set up a plan, and I'm going to create a plan, and I'm going to do azimuth N31. We're going to do Andromeda. The reason I'm choosing Andromeda is because I don't want to do any of the framing or anything, but I want it to show the difference in that field rotation and how it can affect the images that we're creating. And M31 materializes fairly quickly, and it encompasses the whole screen. And so it will be a good one to try this on. So I'm creating a plan, and I'm going to add M31. M31. Locate the target, add it to the plan. Now I'm going to do this. I want to do it from midnight until 5:30. So that'll be 5.5 hours of time. And what we're going to do is we're going to compare this object, just doing it regular azimuth mode in a plan all night long, because we want to capture a lot of exposures, because that's what makes the images very brilliant and show the detail. So we want it to do a long time, but what we also want to do is we want the image usable. And so we're going to do an experiment here. We're going to do it this way in azimuth mode, and then we're going to save that plan. And so that's the azimuth 31 plan right there. And then we're going to create another plan, the azimuth mode split plan. And what we're going to do is we are going to also image M31 and locate it and add it. We're going to start it at midnight, but then we will stop it at 1. And then we're going to add that object again, the same object, and now we will add it until 2. And what we're doing is we're splitting up that object so that it basically starts over again like it's a new object. And so if we do it for 5.5 hours, the field rotation is going to be 5.5 hours worth of rotation. And if we do it this way, what I'm hoping it does is it will do an hour of field rotation and then start over again and start another hours of field rotation. I hope that makes sense. So instead of showing the image with 5 hours in each corner, it should only show 1 hour of field rotation in each corner through the whole for every object. And so let me see, I'm getting close here. And the last one I'll do for the last half hour. And so then what I'm going to do on this one is once I've imaged them both, we will compare and see if it really does make a difference. My theory is that the ones that are an hour the rotation will start in the top left corner of the image, and for an hour, that rotation will show up in that corner moving to the right. Well, instead of continuing to move to the right, it should start over again when it starts the second object. It's really not a different object, it's just starting over that object. So we will end up with 6 separate images for this plan, but then at the end, I will do the deep sky stack on these exposures for these six options. I mean, they're separate images, but it's the same object. Hope that makes sense. Kind of hard to explain it in words that aren't going to be confusing, but that is my plan. I want to do an experiment because, not everybody can do EQ mode, or they choose not to, or it's a hassle, or for whatever reason. So I'm hoping that with this experiment, we will learn how to minimize that field rotation as much as we can. Ultimately we could do these exposures even shorter periods of time. I'm doing them 5 of them at an hour and then the last one at a half hour. But we really could do them even smaller, as small as 10-minute exposures. Of course, it's a tedious plan to set up, and you do lose a little bit of time as it saves the object and then renavigates to the object between each session. But that would be fairly minimal in a full night's imaging time. But that's the experiment we want to do tonight, and it's going to take me several nights to do this, and if the clouds don't cooperate, it could even take me more than 2, but hopefully it just takes me 2 nights to image this, and then we will have some results of that experiment. So keep watching and we'll put in the results. All right, it's the next morning. We ran the plan last night without any hitches, and this is the result that we got. I did have to brighten this image in the software I'm using to create the video just so that you can see it more clearly. I could see it clearly on my device without brightening or anything, but I think when I put it on the software, I don't know. I'm not sure it's going to show as much. So I am brightening it so that you can see where that field rotation is in the image. In every one of the corners, you can see where it ends when I brighten it. So that's why I've done that. I didn't do any other enhancing other than that. But this is the image that we got. It recorded for the 127 minutes is what it captured as the Azimuth mode over the 5.5 hours. So the save rate wasn't fabulous, maybe 50% or so. I didn't do the math. That's not what this experiment was about. The rotation is what we were looking at, and if we just did that plan and ran it for 5.5 hours, this is what we got this night. You can see that field rotation almost maybe a quarter of the screen is taken up with that field rotation. And if you were to try and crop that out of this image, it would definitely blur into the actual object. And it would definitely cut down on the viability of using this object. So that's using the 5.5 hours. what we will do tonight, if the clouds cooperate, is we will run that second plan that chop them up into hour segments and see if that will at least eliminate the majority of that field rotation. I'm hoping it does. We'll see if that helps. If we can come up with workarounds for those who choose not to use EQ mode or for some reason can't use EQ mode, we want to come up with the best possible scenario for getting the best possible images. And so that's what we will do tonight. And I will come back and finish the video tomorrow or whenever the clouds allow us to finish. And we will do more with this experiment. Okay, it's the next morning, and I'm going to launch the Seestar app, and we'll see what we were able to save last night in our imaging. So just as a reference again, last night we did the split plan, which should have recorded 6 images. We click on the album and click on the Seestar in the middle, and it only saved 4 right here. So let's look and see which ones. You can see that it did rotate quite a bit between the first one and the last 3. Let's see what times they were at. This one saved at 1 o'clock. So that's the one from midnight to 1. The next one is from 3 to 4. The next one from 4 to 5. And then the one from 5 to 5:30 saved. I think maybe 4 images will be enough for us to get an idea on this one. But let's kind of zoom in a little. This one is only the half-hour one. So let's look in those corners. And this one, I don't see much field rotation at all in those corners. Let's look at one of the longer ones. There we go. We can see. Let's see. See, I just don't see a whole lot of field rotation in these ones. This one is the 4 a.m. to 5. There's a smidge, a little tiny bit down in the corner of that one. Oh, there's a little bit on that one. See, in the right-hand bottom corner, there's a little bit of field rotation. That's from 4 to 5. And that one's the 3 to 4. Well, you can see it. Whoops. It's hard to keep them on line. When we're done here, I will enlarge them. See, there you can see it there in the bottom, that field rotation. Let's see if it's in the top too. But it is significantly less than the ones we took that had the 5.5 hours straight. And we know that the 5.5 hours didn't save every single exposure either. So maybe there's the little bit of field rotation, but it's really not very big. And if we were to crop it out, you probably wouldn't even really notice. And then this is that one, the early one in the night. It looks like it was a little low and maybe near some light because there's light in this one. But see, there's not a whole lot of field rotation in this one. There's some anomalies there. I think it's due to that light that's in that bottom corner. Okay, so what have we learned? Let's see. All right, so we did this one. We should have gotten 6 images. It didn't record all 6, but you can see just from this picture here that the first one was having a lot of light pollution problems. And then the other 3 look okay. The short exposure one looks actually a little darker. That would make sense because it doesn't have as much light saved. I think what we'll do now is, let's see, it saved 721 subs. And I did, before we started this experiment, I did clean off the M31 files off of the Seestar because what I'm gonna do is I'm gonna take the subs, I'll scroll through them and make sure there's not any with crazy light or satellites or something, but, I'm going to stack all these and see how they compare with the image that we saved that was 5.5 hours straight, so that we can see if it does help that field rotation. Um, I'm thinking it will because it's such a small part in the corners, it's just gonna stack the small parts in the corners on top of the other small parts in the corner. It's not gonna enlarge it. So I'm thinking that this experiment is probably going to be a pretty good experiment and we learn something. I'm going to do the stacking, the deep sky stack. For those that don't know how, you just go into we have to go to the main screen. We click Deep Sky Stack. We add images. We go to the M31 subs folder. We can select them all, and then I will scroll through and eliminate any that are really terrible and we don't want to include. But then you just click OK at the bottom, and then it allows you to stack those. And then we will end up with one final image that is a stack of all of those 721 objects. And then we can get a fairly good idea if the field rotation is more prominent when we stack it and how it compares to the one that we did that was 5.5 hours long. And so that's what I will do next is I will stack all those and then I will put up some images that the 4 that we gathered last night, and then I will also put it side by side with the one that we gathered last night with the 5.5 hours, and then I will do a stacked image too. So that's what I will do next, and so I'll bring you back when I've saved all of those files. Here are the 4 images I collected last night. If you look at the bottom of each photo, it'll tell you how many minutes saved on each of those. It looks like it was about 34 to 37 minutes. And then the last one, of course, was only a half hour long, so it will only save 13 minutes of exposures. And so I did brighten every one of these just like I did the one from a night or two ago so that we could look in those corners and see that field rotation, but it really isn't very evident. I mean, you can, if you zoom in on it even more, you can see a little bit, but it's not very drastic. And so these are the 4 images that we got. And next up, I will stack these exposures and we'll see what that final result looks like. For reference, here's the original one, the 5.5 hours straight. These arrows show kind of where the field rotation starts and ends in in that top left corner. This one saved 127 minutes worth of exposures. I did brighten this one so that we could see that field rotation a little more easily. And that same field rotation is in the bottom and in the top. In all of the corners you can see it, but mainly in this top left and bottom right corner, it's very evident. Okay, we ended up stacking 706 images, and it took about 35 minutes to stack those, and here's the result. So this was pretty interesting. If you notice in the bottom right-hand corner of each picture, it tells us how many minutes are in this, or exposure time is in each image, and the one on the left is 127 minutes. The one on the right is 118 minutes. So they're really relatively close in exposure time. I did brighten both of them in the software I used to create the video so we can see that field rotation a little bit better, but the pictures are drastically different as far as the field rotation goes. You can see that it has rotated over the course of the few days, the object itself, but when we're looking just for the field rotation, it's evident that the left-hand picture has a lot more field rotation. So what's the summary of this experiment? Did we learn something that we needed to know? The exposures on the left was 5.5 hours straight. The exposure on the right was in 1 hour increments. Of course, it didn't save an hour straight, but the exposure time's about the same. So we did learn in this experiment that we can reduce that field rotation when we're using azimuth mode. So if you're one of those who doesn't want to do EQ mode for whatever reason, there are ways to reduce that field rotation so that you can get a, a good image that you don't have to crop out too much of the image. And so this was a fun experiment. As a bonus, I'm going to put a picture of an object I gathered right before I was waiting for this plan to start, just because I love this object. And I was imaging it before the plans for these ones started. You probably noticed this image in the folder in my album when we were gathering up those images from last night, but this is one of my favorites. This is M16, the Eagle Nebula, and if you zoom in really close, you can see those pillars of creation, and I just love this one. I do it every chance I get because it's just one of my favorites. I haven't done any editing. This is just straight off of the Seestar, and it's not a very long exposure. This is only 33 minutes of exposure time, but I'll zoom in on that pillars of creation because I just think they're fascinating. Just 33 minutes of exposure, and then those pillars of creation just pop out of there. Of course, we could get it to be better with some post-processing and stuff, but I really like imaging and showing what the Seestar can do, and this is M16. I hope you enjoyed this experiment with the exposures and the field rotation, azimuth mode, some options that we can do to enhance those pictures. Um, if you like this kind of experiment, give us a thumbs up, share and like the photo, give us some comments about some other experiments you would like to see done. And we're always wishing everyone clear skies. Thanks for watching.